So it's my pleasure to introduce our next speaker, David Mettler. He's going to give kind of an overview of the projects that we've been going on in the research department, because we don't have time to go to all of them in super deep depth, so he's going to get the high points to you. So, David.
Thank you, Todd. And despite what Paul said, this might not be as exciting about learning how well the factory's doing, but I'll give it a shot. So I'm going to talk about a few projects, as Todd said, not everything that we've been doing in the last year, but just to highlight mostly of nutrient management trials and some rhizoctonia. So these are the 6 trials I'm going to talk about. First one being a previous crop trial. So the idea behind this trial is we wanted to investigate the differences that we see from the ag practice database, but also the differences in previous crops from other co-ops. So if we look at the ag practice database, you can see that for previous crops, we mostly follow field corn. However, we do have some of our acres that follow soybeans, peas, silage corn, and sweet corn, but vast majority on the field corn side of things. If we look at the database, and again, this is just from 2023, sorry, I should have mentioned that. This is just from last year. If we look at the extractable sugar per acre, you can see that we have a similar yield for the field corn and soybeans, but a significantly higher yield on the sweet corn, peas, and silage corn. So this is how we kind of picked out our treatments for our trial that I'm going to talk about here next. You can see small grain was not shown. We didn't really have enough fields to compare against these other ones. A very limited number of small grains are used as our previous crop here at Southern Min, compared to the majority of the sugar beets up in the valley following small grain. So this is our trial setup. This is a 2-year trial at each location. So there's a lot of details here, but we have 2 sites, one in Bird Island in 2021, another in Hector, 2022. We had field corn, soybean, sweet corn, and spring wheat for our 4 previous crops. Doing peas as a previous crop on small plot research, I didn't really want to do that. It'd be a lot of hand picking of peas. We have our 3 most common previous crops for Southern Min, comparing that against spring wheat that's used majority of the other co-ops, like I said. Planting date, harvest date, and then our yield per acre at both sites. You can see that pretty typical yields that you might see in our area, with the exception of the field corn in 2021. If you guys recall, it was a rather dry year, especially in that area, so the field corn took a hit at that location. Part of this trial was also a nitrogen component. So we had the previous crops as one factor, but then we also added the factor of nitrogen rates. So for our nitrogen, we had the residual nitrogen that was present in the plots. We fertilized up to 110 pounds and then also up to 150 pounds, which if you recall, that's kind of the recommended nitrogen range is at 110 to 150. So that's what we use for our 2 nitrogen rates. The residual N is based on a 4-foot sample that was taken in the fall. This is the Bird Island location in 2022. You can see field corn and soybean very similar for residual, sweet corn higher residual, and the spring wheat quite a bit lower. Spring wheat being lower, it's not surprising given the situation where when we harvest, we generally have a little bit of harvest loss, and a common practice is to let that regrow as a cover crop, right, a volunteer going into the fall, and that kind of sucks up a lot of the nitrogen that would have otherwise been available if the crop was terminated. So this is the 2023 Hector location. Again, this is just our soil residual down to 4 feet, very similar for the field corn and soybean again. Sweet corn was a little bit higher this year, and then our spring wheat again a little bit lower. So looking at quality data from 2022 and 2023, this is across all of the previous crops. So we're just looking at the nitrogen rate averaged across all of the previous crops. And so the residual there has an asterisk because it varies depending upon what the previous crop had there, right? And then they're all fertilized up to 110 and 150 with spring applied broadcast urea. You can see for extractable sugar percent, extractable sugar per ton and purity, that we had a little bit of a decline in our quality going from the residual N or the 110 up to the 150. Not a huge difference between the residual and 110, but significantly different going up to that 150. However, we all know that we do need to add some nitrogen, right? Otherwise, we're not going to have much of a root yield. So looking at root yield, you can see this is 2022. This is our tons per acre, and we have our 4 crops here, the field corn, soybean, sweet corn, and spring wheat. Now, these lines don't all start in the same spot because we started each of these crops at a different residual nitrogen, right? So you can see that the spring wheat, soybean, and field corn are down here, a little bit lower residual N. However, when we fertilized up to 110 for all of the crops, they all had a very similar yield here. Fertilizing further up to 150, not a lot of difference there, fairly flat if you compare all of them here. The sweet corn, however, didn't change much in yield. It started with a lot higher residual nitrogen. Looking at 2023, a little bit of a different story here. If you look again at the same crops, we have our soybean and field corn. Fairly similar residual, increased a little bit in yield, very similar in their overall yield. If you recall what I showed earlier for the Ag Practice database, that was also similar across the grower fields, that the sugar beets following field corn and soybean had very similar yield. However, for the spring wheat and the sweet corn, we had a little bit higher yield overall. You can see the yield bounced around a little bit with the nitrogen rates. But overall, the spring wheat and sweet corn were a little bit higher. So again, we saw an increase in root yield from our residual N to 110, but didn't really see much of an increase going from the 110 to 150 for the total nitrogen. So following a previous crop that has a lower amount of residual going into the fall that has the opportunity to break down, we're harvesting the sweet corn or the peas in August. It just has a lot more time to break down and have a nicer seed bed, but also not be tying up nitrogen going into the following year. It also isn't taking up any nitrogen that's mineralizing in the fall, making it more available for the sugar beet crop early in the spring when we need it. So going on to another trial here, we have a phosphorus by nitrogen rate trial. So a lot of these trials stem from grower questions, right, on, well, do I need to be increasing my rate of phosphorus as I increase my nitrogen rates? So that's kind of how this trial came about. And you can see in the picture that we do have some difference in the canopy of these different plots here at the site. This was taken in mid-June, so you can see quite a bit of difference there in the canopy. So looking at nitrogen, we had 3 different rates of nitrogen. Our residual N, so that was a soil sample down to 4 feet, we had 33 pounds of N. We fertilized up to 103 and 173 for our total nitrogen. For our phosphorus, we had 5 rates. Our residual check, so our soil test there was at 3 ppm, so a rather low soil test for phosphorus. And then we added rates of P2O5 increments of 15 pounds, so 15, 30, 45, and 60. And here we're just looking at root yield in tons per acre. You can see the phosphorus treatments here as we added nitrogen to those different phosphorus rates. We increased our yield for the higher 3 phosphorus rates, but we didn't really increase yield as we added nitrogen to our check or our low phosphorus rate. When we went from 103 to 173, we had a flat yield here for the 3 higher rates of phosphorus and no increase or a decrease even in yield for the lower 2 rates. And that's because we had a deficiency in phosphorus, right? It didn't matter how much nitrogen we added to those plots. They weren't going to increase in yield because we were deficient in another nutrient. So looking at it from the other angle, these are our nitrogen rates here now in the lines, the residual being the 33 pounds, and then the blue 103 and the yellow 173, with our phosphorus rates here on the x-axis now. So we can see as we increased our rate of phosphorus across the nitrogen rates, we had an increase in yield by adding up to 30 pounds of P2O5, but we were flat after that with no additional increase in yield. However, for the residual N, we didn't really get an increase in yield by adding more phosphorus because, again, we're limiting in a different nutrient, nitrogen. Looking at our quality parameters here now, we're looking at just the nitrogen rates here. Again, total 33, 103, 173. we can see that we had a little bit of a decline in quality going from that 103 to 173, but no difference between the residual and the 103. So, if you have a low soil test, maybe something that's in the low teens, it's probably a really good idea to add a starter. Make sure that you have enough phosphorus available early in the spring, especially when the soils are cool. Or if you have an even lower soil test like we had, you're probably going to want to add a phosphorus source like MAP or DAP. You'll notice that I didn't really put up any quality data for phosphorus. It did not impact quality, nor do we expect it to. And we did not see a benefit to adding excessive phosphorus rates just because we had a higher nitrogen rate. Just something that was interesting for the phosphorus rate that we had for our soil residual, we should have been putting on up to 55 or 80 pounds of P2O5 according to the university recs, and we didn't see an increase up to that rate, only up to 30 pounds of P2O5. So that's something that we're going to keep an eye on in future trial work, that we might be applying more phosphorus than we really need to for some of these fields. So this trial is very similar. Potassium by nitrogen rate trial, again, a grower question of, do we need to increase our potassium rates as we increase our nitrogen rates to better utilize all of our nutrients? So this is a drone image again from the same field. You can see a little bit of a difference in canopy, but not quite as drastic as the phosphorus trial. This is a combined data set from 2021 to 2023, however. So all the data I'm presenting is going to be an average of those 3 years in a combined analysis. So looking first at potassium, you can see we had potash applied, K2O. We're going in increments of 30 from 0 to 120. And if you just look at this table real quickly, you can see there's no significant difference in any of these parameters that were tested for potassium. This isn't really a surprise to us. It's hard to find fields in the majority of our growing area that are going to be low in potassium. For our fields, 2 of them wouldn't have been recommended to apply any potassium, and the other one would have just been recommended to apply maybe 15 pounds of potash. So not really deficient in potassium on these fields. However, if we look at nitrogen, we had a little bit of a mixed bag for results, increasing nitrogen rates for this trial. If you look at this graph, we have extractable sucrose in pounds per ton. You can see in 2021, we decreased in quality as we increased our rate of nitrogen. In 2022, we increased our quality, and in 2023, it was fairly flat. So really just every possible way we could have went here for our response. The 0 here is residual. 1's around 130, and 2 is going to be close to 200. It varied a little bit between sites. So this is going to be an average that I show on the next graph, or table, excuse me. So again, just the average between the 3 sites is kind of where we lined it up for our level of nitrogen. And you can see in our root yield, we're around 30, 31 for the residual nitrogen, 36 for the 130 pounds roughly, and then just a little bit above that, 36.5 for the 200 pound rate. So again, if you do happen to have a low potassium test, not common again for most of our growing area. However, I'm sure if you go north, you'll see some of that. But we didn't see any benefit to adding more potassium just because we were increasing our rates of nitrogen. Okay, so next trial. Sorry, yeah, we were given a snapshot, but we have to go through these pretty quick. And I will note that these full reports are going to be on the research report on the website. So if you get lost trying to follow this through, it'll all be on the website. So nitrogen placement and rate trial. The idea behind this trial was, can we better utilize nitrogen, be more efficient with our nitrogen that's being applied if we place it closer to the row. So here's a 360 Bannet system. It's set up as a 3x1 or 3 by 3/4 of an inch roughly. It's fairly shallow compared to what you're doing in field corn. You can see that system that we added to our planter here. So we're going 3 inches on either side of the row and then 3/4 of an inch deep roughly. It's hard to see on the picture here, but we also did a surface dribble 3 inches either side of the row as a comparison also. So we had 2 sites in 2023, one near Claris City following field corn and another near Murdoch following soybean. We did the same thing in 2022 with one of field corn and one soybean. And in both years, we did not get a nitrogen response following the soybean site. We did get a response following the field corn site, so I'm just going to show the data from that site for today. So looking at 3 different components of this trial, it was a rather large trial, so I'm going to break it up into 3 segments. The first one being a nitrogen rate comparison. So this is just comparing rates of spring broadcast urea worked in with a field cultivator. Our soil residual test was 39 pounds, and we increased that by rates of 30 pounds of total N as we go along the x-axis here. And just looking at root yield in tons per acre, you can see that as we added urea or nitrogen here, we increased our yield going up to this roughly 99 to 129 here, with no statistical difference here really after 130 pounds. If we look at our percent sugar, you can see that our highest sugar percentage or content here was at some of the lower rates, the 69.99, with a little bit of a ding here potentially at the really high rates of nitrogen. Second component is the nitrogen placement, so that's looking at that 3x1 or 3x0. Is it more efficient or more available to the beet plants when they need it? So percent sugar, blue bars, the tons per acre root yield is in the orange. If you look at the sugar, there's really no difference going across here between any of the treatments. However, if you look at the root yield, there is a little bit of a difference there. If you look at our check, the 39 pounds of residual, some of the treatments have a higher yield compared to the check, and that dribble on the surface here at 69 is also a little bit lower than some of the other treatments. The third component I'm going to talk about is nutrient enhancement alternatives. So I kind of made that up because I don't know what to put these all in as a category, but basically we're looking at some products that either make the nutrient more available to the plant in the soil or improve the uptake of the nutrients to the plant, right? Kind of those type of products. In this year, we didn't see any difference on this trial site for percent sugar in the blue again, or in the root yield in the orange. No statistical differences there. So just a real quick synopsis of that trial. So the nitrogen rate comparison, we saw a slight bump in yield going up to those a little bit higher rates, but also saw a slight decrease in quality with the really high rates. Nitrogen placement comparison, we really didn't see much of a difference between the broadcast compared to the UAN that was applied closer to the row. However, I would caution the use of the dribble, especially in a drier spring. You might, you might lose some of that if you don't get a rain and get that incorporated. Nutrient enhancement alternatives, again, we just didn't see a benefit this year or in the last couple of years when we've done testing. Just a note here too from the Ag Practice database. This is again just from 2023. This isn't like the average of the last 10 years or anything. This is looking at the Estesa score, which is a factor of yield and quality, and total nitrogen on the bottom for these ranges, 100 to 140, 141 to 180, and 181 to 220. You can see we didn't see any difference here in Estesa across this range of 100 to 220. We didn't have enough data or fields below 100 to have any data there or above that, so that's the range that we had data for. So it kind of supports what we saw in the small plots where we had a plateau in the majority of the trials here that I showed today after we got over this 100, 120. Okay, looking at manure. So this is a pressed liquid dairy manure trial. So the idea behind this trial, or the question is when do we put on liquid dairy manure in the sugar beet rotation? So, our idea or our thought is that liquid dairy manure applied ahead of sugar beets is going to cause a negative effect on our quality of our beets, right? That's the idea going into this trial. So we wanted to see if we could apply it in the year before beets, or should we be applying it after beets, ahead of corn? Where does it fit? So you can see in this drone picture we have field corn, sugar beet, and soybean for our rotation. So in year one, or the fall before year one, we applied all of our liquid dairy manure treatments. Went in the following year, planted our crops. We have a three-year rotation. We completed that 3-year rotation, and this last year we applied dairy manure again, in the fall of 2022, and we started the rotation again here in 2023 with, again, the first year after the liquid dairy manure. So I'm just going to present the data from the first year following liquid dairy manure application. So this is the results for the sugar beets. I'm not going to talk about the corn or the soybeans, but for the sugar beets, you can see that we didn't have any difference in our treatments here. We have commercial fertilizer, the low rate of liquid dairy manure, and the high rate. No difference in the quality or in the yield. You can see a little numeric difference here, increase from the commercial fertilizer to the manure, however. This is a picture from year 4. So again, this is the year following a liquid dairy manure application in our sugar beet plots. Our commercial fertilizers here, and you can see that there's quite a bit of difference between the commercial fertilizer canopy and the high rate or the low rate of manure. So here's our treatments again, the fertilizer, low and high rate. You can see again no impact on quality following that fall application of dairy manure. However, again, we see a numerical increase in our tons per acre. And I decided to do a combined analysis from year 1 and year 4 because they were both following that fall application of dairy manure. And you can see that we did have a significant increase from the commercial fertilizer check to the dairy manure application. So we saw an increase in tons per acre, no impact or no negative effect on quality following that liquid dairy manure. Now that might not be entirely due to nitrogen, right? There's other things available in manure that could be making an impact there as well. However, just one word of caution is that the database would suggest that the long-term use of manure can have a negative impact on quality, and this is just looking at 1 and now 2 applications of manure in that field history. So it doesn't have a long-term use of manure in that field. Okay, last trial. So this is our Rhizoctonia management trial. So every year we try to conduct 1 or 2 trials looking at either new products or comparing practices on how we can best control Rhizoctonia. So this is a drone image of our trial south of 212, close to the plant. Planting date, May 23rd, so that's fairly late in the season, so the soils are going to be a little bit warmer. We used inoculum provided by Dr. Ashok Chanda for inoculating this trial. It's an infected barley kernel that we broadcast across the trial and work in ahead of planting. So this combination of later planting, warmer soils, plus inoculum created a very heavy pressure environment for the sugar beets. You can see here the disease out in the fields, kind of close up. This is even late in the season. I'm losing large plants to Rhizoctonia. And one thing that I want to mention here is I did plant to about a 60,000 population, right? That's pretty typical for all of my trials. And we take stand count ratings several times throughout the season for Rhizoctonia. We take one shortly after emergence, 28 days after planting, after our post-application, and then again right before we harvest the beets. So we defoliate, count the beets that are left out there at the end of the season, and then lift. Unfortunately, for this trial, we had a very, very heavy pressure, like I said. My stand counts went from a 180 shortly after planting down to the best one being around 110 plants. So a very heavy disease pressure situation where the best treatments are even not performing that well. So looking at stand counts, this is the stand count from right before harvest, and then root rot ratings from a 1 to 7 scale. So we harvest the center 2 rows of each plot. Those beets come up onto the lifter, and we're able to kind of sort through those and give a rating for the entire plot up on the lifter. So that's where that rating came from. And so up on the lifter, we also collected our quality samples. For this trial, we used 1 disease-free sample to go to the quality lab, and then 1 sample that we felt was representative of the plot. So depending on how high of disease we rated it, then it got a little bit more of the disease beets into the quality sample. So looking at this graph, we have, again, the stand counts here in the blue, and the orange dots here are the root rot rating. And you can see that overall our control didn't fare very well. However, it was similar in control to some of the biological products that we were testing at the time. The best treatments for root rot were ones that contain an azoxystrobin product. However, overall, because of the heavy pressure environment, the one that performed the best was a in-furrow application followed by a post. So this is just showing that root rot rating scale from the 1 to 4 here. I didn't go to 5, 6, 7 because you're not really lifting very many beets at that point. For our trial, again, the 1 to 7 rating. So the average sugar content for our disease-free beet samples that we submitted was a 17.5. When we looked at our plots that had a rating of a 2.1 to a 3, the average for those plots was a 17.2. The plots that had a rating of a 3.3 to a 4, our average sugar was a 16.9. So you can see that if we assume that we don't lose any yield, right, which is a huge assumption when you have this much rhizoctonia, if we assume that that's constant, we still lost $64 per acre from that rating that's between the 2 and the 3, and $128 per acre when we go in that 3 to 4 range. And so that's just looking at the quality, not even the impact of yield. So I just want to thank especially our university collaborators who help us quite a bit, Dr. John Lamb, Melissa Wilson, Dan Kaiser, helping us with our nutrient management trials that I presented today, and some others that I didn't talk about. And then also Dr. Shukchana for helping us with rhizoctonia inoculum. And also just to all the other staff at SMBSC who do a lot of the work for these trials. I'm just the one who gets to stand up here and present. So, also another note, the 2023 research report should be posted on the website or will be shortly with all these trials on them. So I'm guessing I have a couple minutes for question.
A couple questions for David?
Yes.
Your Rhizoc trials, the post-applied, is that banded or broadcast?
Yes, so the post-applied treatment, it was banded, 11-inch band. I believe I had some broadcast treatment comparisons as well, but that was in the other trial. Yes.
David, in your manure trial, when you have the strong canopies compared to conventional fertilizer, do you see more phosphorus coming in early? Do you see any differences in those plots?
Yeah, so question was, in a situation like the manure trial where we have quite a bit of a difference in canopy, do we see a difference in the onset of Cercospora leaf spot? That's not something I was looking at in particular. However, we were using a high Cercospora tolerant variety, and we were still making pretty regular fungicide applications because of the tight rotation, so we didn't develop any disease really on that trial site. Okay, if no other questions, I'll be back up later, so you can always ask me again then.